Let's get started. You guys picked up here on the side your this problem here, which we're going to do together, okay, this cone problem. And you're going to see it again. I think it's on your assessment, your relevant app. It might be on your test. Actually, I'm pretty sure it's on your test too. And then this problem here, this right here is your quiz. Okay, so you can start working on your quiz, but here's the thing. I promise you you'll have enough time. And if you start working on it, you're not going to understand the cone problem. All right. All right, here's your warm-up. Again, put a starter. Go ahead and draw this cylindrical tank. Oops, it's not supposed to be bulging on the sides. Okay, so we've got a cylindrical tank. What we know about it is it's 10 inches tall, okay, and this should say 4 inches. And so we know the radius is 4 inches. So I'm going to draw the radius here, which is 4 inches, okay. And there's oil in this tank. It's originally full, okay, so the level of the tank is full of oil, and the level goes down. And it's dropping, the level is dropping at a rate of 0.5 inches per second. So can someone help me with this in calculus talk? The height is dropping at 0.5 inches per second. dH dt, so you want to call this h, that's cool with me. All right, we're going to call the height of the oil h. And so what we know is dH dt is equal to what? 0.5. Would you do anything with that 0.5? Like, right? Isn't it dropping? Okay, so I'm going to put a negative 0.5 here. And guys, in some problems, you must have that negative. It's super important. In other problems, it ends up not really affecting the answer. But in some problems, it does affect the answer. All right, so this is negative 0.5. Find the rate at which the volume of oil is changing. So what am I looking for? dV dt. So my question mark is, what is dV dt when what? What's my moment in time? When h equals 6. Is h always equal to 6? No. So that I'm going to use after I take the what, guys? Derivative. After I take the derivative. All right. I've got my setup. Let me step back and look at what I've got. I've got V. I've got H. I've got a cylinder. What is my formula? V equals pi r squared h. Do you have that memorized? Think about volume as just the area of the base times the height, okay? What about if I wanted to do the volume of a cone? I would take that and divide it by 3. Same thing and divide it by 3. All right, so what I'm going to do now is I don't want V. That's not very useful to me. I want dV dt. What I'm going to do is I'm going to take the derivative of both sides. So d dt of both sides. What's the derivative of V? dV dt. What's the derivative of pi r squared h? 2 pi r dt times h. You guys get the derivative first times the second plus derivative of the second, which is dH dt times what? Pi r squared. You guys good with that? Do you guys feel itchy? Are you breaking out in hives? A little bit. It's because you're allergic to product rule. Okay? And I need to tell you, you actually don't have to use the product rule here. Because if you think about it really, really hard, okay, right here, this volume equals pi r squared. Does your r change in this problem? No. Does it need to be a variable? No. No. Only if it's a cone problem, right? This is a cylindrical problem. What is your r here? 4. When my oil level goes down, what's my r? Okay, do you guys see it never changes? So this problem is simplified. And I just need to tell you guys, if you do product rule on the exam, what you need to do is r is constant. What is dr dt? It is 0, okay? And I know someone's going to do it, okay? And if you do product rule, just know, well, dr dt is going to be 0, and it actually will still work out. All right, but it's way easier, okay, to notice that this r is constant. So guys, what's r squared going to be? 16. And that formula is way easier, okay, to take the derivative of than the original one we had. All right, so now I'm going to do the ddt of both sides. What's the derivative of v, guys? dv dt. What's the derivative of 16 pi h? 16 pi, but don't forget dH dt. So 16 pi, but we have implicit differentiation going on. DHDT. All right. Can I plug in? Go for it. So what's my DHDT? Negative 0.5. Do you guys notice you actually never have to use this H equals 6? You see that? It's extraneous information. But it's nice. It probably made you feel comfortable when you wrote it. It made you feel happy, right? So sometimes we just do things not because we need it, just because it makes us feel happy. Okay. All right. So dV/dt is equal to, and see if this makes sense to you, 16 pi times negative 1/2. Okay, which is really just negative 8 pi. Guys, if you're using the calculator, don't get used to it because on the test you're not going to have a calculator for this test. Okay, so make sure you can manipulate these fractions. And now I just need just for volume. Go find a length and just cube it. Go find a length and just cube it. Inches cubed. What about time? Go find me a time. Is it seconds? All right, and we're good. And guys, again, you can't do this probably when you go to college, but on the AP exam, they're not going to trick you on the units, so we can do that on the AP exam. All right, dV/dt. Am I done? Okay, make sure you put a star by it. Make sure you understand that R is constant with cylinders. R is not constant, though, with what? Cones, all right? So make sure when you do a cone problem, you understand that you have to do something different. All right, guys, quickly, can you tell me the answer to this expression? A, B, C, or D? Yeah, it's B. Okay. Why is it not sine? Because this is the definition of a derivative, okay? So once you figure out that f of x is equal to sine x, you actually have to do one more step. You actually have to know what the derivative of sine is. And some of you guys, okay, on your test, you actually needed to know the unit circle. Sad face, okay? So make sure you guys know the unit circle. All right, this one you didn't have to. Oops, I didn't mean to hit that one. Okay, guys, let's look at homework from last night. What problems would you like to do? Homework from last night.
Like the entire batch.
No, let's do one problem.
Okay.
1 to 2. We have time, but I don't want to do the whole thing.
Do 8.
Okay, let's look at 8, guys. Homework from last night. Okay, guys, we're looking at 8. Guys, definitely you need to know this for the test. Okay, a person walking either towards the light or away from the light. Okay, but if you draw these pictures, they always look the same. Okay, it's a similar triangles pictures. Okay, you got this kid. Let's make him a. Okay, so you got this kid, and he's 4 feet tall. Does his height change as he walks? No. So he's always 4. The street light is 16 feet tall, so there's my light. Guys, when the light shines, whether the boy is walking left or he's walking right, okay, the shadow is always in the same place. You guys good with that? Where is the shadow? Behind him, okay, or in front of him, depending on which way he's walking. But it's always over here, so that's the length of the shadow. The rate that he walks, or where he walks, is always this length right here. So let me call it x. So maybe you guys should just memorize this. But students have trouble drawing the picture, okay, and the picture always just looks like this. All right, so now I've got this 4-foot child walking away from a 16-foot lamp, and he's walking at a rate of 2 feet per second. Calculus talk, guys. What is 2 feet per second? What is it? Dx dt. 2 feet per second. Is x increasing or decreasing? Let's think about that. Is he walking towards the light or away from the light? Away. So you guys okay if I just leave that positive? Okay, so 2 feet per second. And the question is, what rate is the length of the child's shadow increasing? So what am I trying to find? Du dt. Okay, when, well, actually, I guess not when anything. It's just I'm just trying to find du dt. Take a step back. I've got a similar triangles picture. I've got an x. I've got a u. What's my formula? Do you see it? U to the s is to 4 as what is to 16. And so many students put x down here. It is not x. What is it down here? U plus x. It's a big triangle. All right? So u is to 4. Actually, let me change it to this. 4 is to 16 as u is to u plus x. I'm doing it on purpose hard. I mean, I'm making it look terrible on purpose. Okay? Right here, guys, what students want to do is they want to take the derivative of both sides. But it's way easier to do what first? Cross multiply, okay? Guys, when you take the derivative of both sides, you decide to do ddt and ddt, do you see that this is going to be quotient rule, okay? Do you feel itchy? That's because you're allergic to quotient rule too, okay? So what you want to do is try to figure out a way that you don't have to use product rule and quotient rule. And I got to tell you, sometimes you just do, okay? But on this problem you don't, and on the cylinder problem you don't, okay? So on this problem, what could I do instead? Cross multiply. You can cross multiply when you have one fraction on the left, one fraction on the right, and an equal sign in the middle. Okay, that's the only time you can cross multiply. So what I'm going to have, and see if this makes sense to you, that 4 needs to be distributed. You guys okay with that? Actually, we can even, can I divide everything by 4? You guys okay with that? Yeah. So this would be 4 plus x equals 4u. And I don't know why I didn't have this same, I did this in first period. I had all different numbers. You guys might want to fix first period's problem. I don't remember this in first period. But anyway, 4 over 16, that looks right. U plus x equals 4u. I can take the derivative here too, but does anybody see anything else I could do? Yeah, you can move the u over. So this could actually be x equals 3u, even nicer. Okay. What do I do next? Let's go for it. Okay. That was good, Natalie. Okay. You guys good? Take the derivative of both sides. What's the derivative of u? 1 du dt, or dx dt. Did I ask for u? Yes. Sorry. What's the derivative of 3u? 3 du dt. Do I know what du dt is? No. Do I know what x is? Yeah, 2. So do you see I could solve for du dt, which is what I'm trying to find, and that's just 2/3. Guys, let's get the units on this one. What's the units of the distance u? Oops, let me go find it. Feet. What's the unit for time? Seconds, and I'm done. Okay, how are you guys feeling? Guys, make sure you can do this. I would put a double star on this problem. All right, what other questions do you have?
Can you go back to the answers?
The answers, yes. I don't know where it is, but I'll try to find it. And it was posted online too, Afiq, just FYI. Okay, there it is. Okay, let's do one more problem, guys, and then we're going to move on to the cone problem. I could, but does anybody else have another question? Since I think you called the other one.
I was hoping for 5 also.
Why
is there 2 answers?
Oh, it's because I probably changed your warm up from other years. I changed your homework from other years. That's why. So don't worry about it. Sorry about that. Okay, let's do number. Did you say 5, Brent? Or
yes.
Charles? Somebody? Okay, so let's go to 5. Oh, the final problem.
Yeah.
Okay, yeah, let's do it.
I thought it was easy, and then I did it, and I was like, whoa.
You can do it. Okay, we've got a funnel being empty of fluid. So here's my funnel. Okay, empty of fluid at a rate of 12 cubic feet per second. You guys good with the calculus talk here? dV dt equals negative 12. I'm going to leave the units out, but it's nice if you do put the units, all right? The height of the cone is 20 centimeters, and the radius of the cone is 4. So what I have is this is 4, and this is 20. Okay, this is 20. All right. Then the question is, how fast is the fluid level dropping when the level stands 5 centimeters above the vertex of the cone? Wait, is there any other information I need here? 12, 24. Okay. How fast is the fluid level dropping? So I've got fluid in here. Okay. Guys, can you guys tell me, what am I trying to find in calculus talk? dH dt. Okay, so I need to label this h anyway then. This must be the height h. All right, so dH dt equals question mark when what is 5? H is 5, okay? So guys, I've got a cone, I've got H, I've got V, I've got R. What's my formula? What is the formula for a cone? 1/3 of the cylinder, okay? And so what you're going to do is what dVdt, you want dV dt. So what you have to do is take the derivative of both sides. When I take the derivative of the left, do you see you get dV dt? When you take the derivative of the right, do you see you get 2 pi over 3 r dt? You guys breaking out? You want me to stop yet? Times h plus dH dt Derivative of the first times the second plus derivative of the second times the first. Okay? Yelling out on me? Okay. This is great, okay, but it's hard. Is there another way to get this so that all of these are one variable? Do similar triangles, okay? When you're on your test, okay, and you start breaking out into a rash, okay, know that it's probably, you can simplify the problem somehow, okay? And so know this is similar triangles. You have two triangles here. One here is R, oops, sorry, the R is not there. The H is here. H versus R. And the other similar triangle is what, guys? 20 and 4. So what you know is H is to R as 20 is to 4. And I can call that 5 to 1. All right, guys, on this problem, they give me DHDT. So what would I like to change everything to? H's or R's? H's. Guys, if you want to change everything to H, then solve for R here so you can plug in. So if I'm going to solve for R here, I'm going to cross multiply, and I'll get 5R equals H. So therefore, R is equal to H over 5. I really don't want R, though. What do I really want? R squared. What's R squared here? So that's going to be pi over 3 times H squared over 25 times H. And if I simplify that, I get pi H cubed. Someone give me a check on that. Pi H cubed over 75. Right? Okay. So then this is way better than that product rule. You guys good with that? Okay. So your rash is gone. All right. What do I need to do next? Take the derivative of both sides. Do the d dt of both sides. The derivative of v is dv dt. What's the derivative of pi h cubed 75? I see that is really, remember you can take the numerator and shift it down a bit. Only if everything's being multiplied. Okay, you can drop it down a little bit. And let's take the derivative of this. Isn't that really like, right, 3 pi over 20 over 75, which is pi over 25. H squared, don't forget what though? dH dt. All right, I'm almost home free. Okay, what is my dV dt? Negative 12. Do I know my H at a moment in time? It's 5, but this would be H squared, right? So 25. And there's your dH dt, and I'll leave it up to you guys to finish up the problem. Okay. All right, let's go to the cone problem. So pull out your worksheet here that you guys picked up. I'd like to do this with you guys, and then you guys can be free for the test. For the quiz, sorry. Okay, so let's look at your cone problem here. Guys, this was an AP problem in the early 2000s, okay? And they give you this cone, and they tell you all these dimensions that they marked on this cone. And then they tell you that the water in the container is evaporating so that the depth is changing at a constant rate of negative 3/10. Guys, what is that in calculus talk? dH dt. So go ahead and define that. dH dt equals negative 3/10. And again, it doesn't hurt to write the units, okay? But you don't have to. All right. The first question is find the volume of water in the container when H is 5 and indicate the units of measure. All right. Find the volume of the container when H is 5. So let me just go ahead and write down my volume formula. So that's 1/3 pi r squared H. And they actually tell me what my, I forgot I was going to say. What my volume formula is, okay? But let me tell you guys, on your test, they may not tell you, all right? Teaching theater, okay, thank you. Teaching theater, okay. All right. So guys, we know volume, and the question is this. Think about the question. The question is, what is the volume when H is 5? So what does that mean? That means I'm going to take this H and turn it to a 5, okay? Is there a derivative involved here? Guys, this is a geometry question. Okay, so many students on this question, on the test and on your relevant app, they want to take the derivative. It's not a derivatives question. It's not a calculus question. It is a geometry question, okay? Moment in time has nothing to do with this, okay? There's no derivative in here, okay? H is 5. What is R? Do you know R when H is 5? Well, let's think about it. This is H is to R, right? H is to R as what when what is to what? As 10 is to, be careful, 10 is to 5. You guys good with that? Similar triangles over here. What you'll get is H is to R is 10 is to 5. Why is this not 10? Because it is the diameter that's 10. The radius is 5. Okay? So you're going to put on the side H is to R as 10 is to 5, which is really 2 over 1. Okay? I want to solve for R, so I'm going to cross multiply. I get 2R equals H. But do I know what my H is? For this problem, it's 5. Okay? I can plug in. So R is equal to 5 over 2. Okay? So right here, this will be 1/3 pi. Guys, if R is 5 over 2, what's R squared? 25 over 4. Okay, so this is going to be 125 over 12 pi. And let's get our units right. What's the unit for volume? Centimeters cubed, and you're done. Okay, so be very careful, guys. This is not a moment in time problem. It's not a calculus problem. It is a geometry problem. Okay, let's go on to the calculus problem, though. Number 2 says, find the rate of change of volume in the container. The rate of change of volume. All right, so here, dV dt. So that means I start with the volume formula. So let me go ahead and write it. Okay, but I eventually want my dHdt, right? dHdt, was that -3/10? They give me that. So what I want to do is change all my r's to h's. Okay, so what relationship do I have? Was it h's to r was it 2 over 1? Okay, so if I solve for r here, is that h over 2? Right, that's a relationship I have with r and h's. All right, so what I'm going to do here is everywhere there's an r squared, what am I going to put instead? H squared over 4. All right, and that's how I change everything to h's here. So this gives me pi over 3, no, pi over 12, right? Pi over 12 times h cubed. Does everybody follow so far? I'm trying to bring this down, but I don't see how to bring this down. Okay, so what we're going to do is we're going to take the derivative of this. So this is dv dt equals, okay, ddt of both sides, pi over 4, really 3 over 12, right? But that's pi over 4, h squared dh dt. Did you get the same thing I did? Yes, no? Okay, good. All right, and we're trying to find dv dt. So can I use my moment in time now? Yes. So what's my h? It's 5, right? So I'm going to change that to 25 because that's h squared. What's my dh dt? -3/10. All right, and then so all I'm going to do here is multiply together. So I have pi over 4 times 25 times -3 over 10. If I divide by 5 there, I'll get dv dt equals -15 pi over 8. Can someone give me a check on that? -15 pi over 8? Yes, no, maybe? Yes. Okay, yes. I heard one yes. Okay, let's get the units here. What's the units for volume? Centimeters cubed. What's the unit for time? Go look for a time somewhere, guys. Hour. And there is my answer. All right? All right. Part C is where students have trouble. Okay, we need to talk about proportion. Okay, so let's go ahead and go to part C. And part C says, show that the change of volume of water due to evaporation is directly proportional to the exposed surface area of the water. Okay, so guys, what if I say that my intelligence, so if I say Chang IQ is directly proportional to Jamie's intelligence, then if I multiply Jamie's intelligence, okay, by some factor k, okay, it's going to come up with my IQ. Does that make sense? Okay, and you guys decide if this is a fraction or not, but it doesn't matter. It just has to be a constant. It just has to be a constant, and that means our IQs are directly proportional. So make sure you understand what directly proportional means. Okay, so look at what they're saying. They're saying, show that the rate of change of water is directly proportional. So they're saying, what's the rate of change of water? Volume, right? dV dt is directly proportional. That means it's equal to K times what? The surface area of the water, the exposed surface area of the water. So guys, when you're on the cone looking down, what is the formula for that exposed surface area of the water? Not 2 pi r, pi r squared, right? Area. So pi r squared. And that's all they're saying. Tell me that this K is a constant. And if the K is a constant, tell me what that constant is. That's what they're saying. Okay? So guys, we remember that V is equal to 1/3. Ooh, that's a 3. 1/3 pi r squared h. Okay? In this problem, unlike part B, we don't want to keep the r's. Do you guys see that? So remember we knew that h over r, what did we know? Was h over r is equal to 2? So h is equal to 2 over r, is that right?
2R.
H is 2r, thank you. So h is 2r. So what we're going to do here is the h instead of h, we're going to replace that with 2r. We're going to change everything to r's instead of h's. So now what I have is 1/3, or really 2/3, right? 2/3 pi r cubed. Okay? But I don't want d, I want what? dv dt. So let's take the derivative of both sides. So dv dt is going to equal 2 pi r squared, don't forget though, dr dt. What is dr dt? Okay, because I've got this pi r squared, which is perfect. This is what I want. I've got the dv dt, which is perfect. But I need to get rid of this dr dt. I need to show that it's some sort of constant. So guys, look how you find dr dt. If I could just find r, isn't r equal to h over 2? Then how do you find dr dt? If you have r, how do you find dr dt? You take the derivative of both sides. What I do here, if I take the derivative of this side and this side, I will get dr dt is equal to, do you guys know? 1/2, but don't forget dh dt. But do you know what dh dt is? Yes, what is it? Negative 3/10. So what you get is a number for dr dt. dr dt is negative 3 over 20. Okay? And since dr dt is negative 3 over 20, you can come over here and just replace this with negative 3 over 20. Multiply everything together, and I think what we get is negative 3 over 10 pi r squared. We are pretty much done. This shows that dv dt is proportional pi r squared by what constant of proportionality? Negative 3/10, and that's your answer. The k is negative 3/10. Do you guys see that? That is your k. All right, so you would say k is equal to negative 3/10, and that is your answer. How are you guys feeling? Good. Okay. Go ahead and work on your quiz. I'm going to head out of here. I will check your homework tomorrow. All right. And your quiz is due today.